Hey guys, in this video I am going to solve a very easy problem of DP which is from Codeforces round 539 and named as Sasha and a bit of relax. So the problem says that we are given an array of n integers and we have to find some funny pairs. So the funny pairs is defined as the range L to R such that the length of this range is even and the first half of the ZOR of the first half of the array equals to the ZOR of the second half of the array. Okay, so the problem is like this. And now how to solve this problem? So the first thought that came into my mind that this is whole subarray. Now what if I bring all these right hand elements to the left side? So it will become like AL ZOR AL plus 1 ZOR dot 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 AR will be equals to 0. So the problem can be converted to find number of subarrays such that the length of subarray is even and their ZOR sum is 0. So the new problem is like this. Now how do I solve this problem? So whenever I see that I have to find ZOR of subarray such that the ZOR should be equals to 0. So the first thing that come into my mind is that I will make a prefix ZOR sum array. Prefix ZOR sum array in which I will store, like at the first index I will store A1, at the second index I will store A1 ZOR A2, at the third index I will store A1 ZOR A2 ZOR A3 and so on. Okay, so this is my ZOR sum array, prefix ZOR sum array. Now how would I get a 0 ZOR sum subarray from this prefix array? Let's say that the ZOR sum at this index is x and ZOR sum at this index is also x. Now what can we say about the elements of this subarray? What can we say about these elements? Now if the ZOR sum is x and also here also x, so we can say that A1 plus A1 ZOR A2 ZOR, like this goes up to A2, this should be equal to A1 ZOR A2 ZOR dot dot dot, let's say this was index int, this ZOR sum will be equal to A of int. Now what if I move these elements towards right? The ZOR sum will be 0 on left hand side and the remaining ZOR sum will be this. So we can see that our remaining subarray ZOR sum is 0. Subarray ZOR sum is 0 when we have same prefix ZOR sum between, not between, at the end of this subarray, at the end of this subarray. Now we have seen that to find a 0 ZOR sum subarray we have to check the same elements in our prefix sum. Now how do I solve this problem? Okay, So what if I maintain some indexes for each XOR sum, like for x it would be index 1, index 2, index 3, like this, and for the XOR sum y the same process follows. Now how did I solve this problem with the brute force solution? So I am given a1, a2, a3 dot 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 an. Now when I move right in this array, I see the prefix XOR sum at this index and I check in my indexes. So I have stored my indexes in like map, where int and vector. So for each XOR sum I have maintained a vector of indexes. So I will ask this index what is your XOR sum, and then I will get the indexes of all the XOR sum from the map. Now I will increase my answer only when this index and the previous index where the XOR sum is the same as this index, if their length is even, then I will increase the answer, and if it is odd then I will do nothing. So this was the brute force solution, and it gave me TL when I submitted it. So I had to thought of some optimization for my solution. Now I thought, what if I could use the most recent index of this XOR sum such that I can get the answer. So I thought of DP at this point. Okay, so now I had to think of states. Now I thought of that I would take one of the dimension as index, and what could be other thing that I should take. Now the problem is asking me to find even length. So what if I maintained something that I get some pairs for odd and even both lengths? Okay, so I thought that I would also consider a second dimension, that it would be like let's say k. If k equals to 0 and k equals to 1, so when k equals to 0, my DP will give me number of subarrays such that let's just erase this k. So when k equals to 0, my DP will give me number of subarrays such that the XOR sum of those subarrays is 0, and the length is even, and all those subarrays should be ending at this index. Okay, so ending at index. So this was the state for even XOR sum, even length XOR sum. And when the k equals to 1, the same will be true but with odd length. So I had defined my state as like this. So I will take index and k, which will show me the length is even or odd. Now the only thing left is transitions. So how do we do transition in this kind of state? So let's say we are given a1, a2, an, aj and an. So I am at this index. Now I had to check for the number. I have to find a number of odd length subarrays and even length subarrays for this index. Now I will just check the prefix XOR sum of this subarray, the most recent one, and let's say it was x, the index x. So how do I do transition from this index to this index? So let's say the number of subarrays ending at this index for odd length is dp of this index was x and 1 and dp of x, 0. So these are even length subarrays and these are odd length subarrays, such that these odd sum ending at this index is 0. This is giving me the number of the subarrays. Now I have to transition from this to this. I have to do transition from this index to this index. How can I do it? So I have to find dp of j, 1 and dp of j, 0. So let's say the length between these indexes is odd. So let's say length between these indexes is odd. So to find the number of odd lengths, we have to consider all the subarrays which are ending at this index. All the subarrays which are ending at this index with even length. This will give me the number of odd length subarrays. Okay. So this will be, if the length is odd, this will be dp of x, 0. Okay. And now to find the even lengths, I have to find all the number of odd lengths and add 1 to it. Okay. So this will be my number of even lengths. So this will be number of odd lengths plus, because odd plus odd will give me a even number. So this will be dp of x, 1. Okay. Now let's see if I am missing something or not. So if the length is odd and the number of even lengths is this number, so the number of odd lengths will be the number of even lengths, and the for even number I have to find dp of x, 1. So odd plus odd equals to even. I think that is fine. Okay. Now if the length is even, if the length between them is even, what happen in that case? So in that case dp of j, 1 will be, so this length is even, we have to find a number of odd lengths. So it will be coming from the odd plus even because equals to even. So the dp of j, 1 will be dp of x, 1. Okay. Now what about dp of j, 0? It will be like, I have to find a number of even lengths. So the number of even lengths here and plus 1, that will be my dp of j of 0. So it will be dp of x, 0 plus 1. Okay. So these are the transition that we have to do in this problem. Okay. So that's it for this video, guys, and in the next video I am going to code for this problem. Thank you.